Hello and welcome to Creativity Uncovered. My name is Abby Gatling and I am on a journey to uncover how everyday people find inspiration, get inventive, and open their imagination. Basically, I want to know how people find creative solutions at home, work, play, and everything in between. And my goal for this podcast is that by the end of it, you'll be armed with a whole suite of tried and tested ways to summon creativity whenever you need it. Now, today I'm speaking with Noah Healy, who is a professional data scientist and recreationally, he's a mathematician, just for fun. And now, if you're anything like me, you probably never thought of maths as a creative field. So I'm definitely keen to find out what it means to be a mathematician just for fun and discover where the creativity lies in that field. So welcome, Noah.
Thanks for having me here, Abby.
So before we start, I kind of want to get a gauge from you because on this podcast, we've had so many different people on here, and it's meant that we've had dozens of different definitions of what creativity is. So before we jump into our conversation, I'd love to know what is creativity to you, and yeah, what does it mean to be creative?
Well, for me, creativity is the production of something not seen before. Uh, and I consider that at a categorical level. So there's a certain creativity in craft. Every time you say throw a cup on a potter's wheel, that specific cup hasn't been produced before. But you can shuffle a deck of cards and produce a sequence of cards that probably will never be repeated again in our universe. Um, so that's not creative, but not actual creativity from my lights. Uh, but the bringing forth of an entirely new idea, even where it has to build on things, that's creativity to me. And in terms of what it means, I think it's a miracle in the palm of your hand. Like that we we live surrounded by things that were brought forth from just ideas and imagination, and we can add more to that list, and it's amazing.
Wow. So do you think that creativity is expensive?
Um, I think, yeah, actually, the, there's certain aspects. The specific thing that I like to pursue is inexpensive economically, but it takes a lot of time and effort for me. I'm not as smart as the smartest people who've ever lived. Um, and societally, there is a cost. Uh, you have to step back from just staying sort of at the coal face, or plowing the furrow, and taking the time and taking the leap of faith that is imagination, and that's a cost. um, and I'm very happy to live in a time when many more people are are available to have that cost, and quite specifically, I am capable of generating enough free revenue that I've been able to carve that time out, without starving myself to death in the process.
Well, that's good. No one wants you to be starving to death. But tell me, why is creativity important to you?
um I think it's sort of foundational. It's a big universe. We have a small piece of it. It's a big planet. We have a small piece of that. Um, there's so much that's possible and available. And while amazing things can happen at our level and at levels that we've been at before, each of those things is leaving aside things that we know for a fact could have been created that would have made them so much more impressive. Um, One of the ones that I typically trot out is block and tackle, which was invented by Archimedes. That means that the the great wonders of the ancient world, from uh, the pyramids, which still stand, to not one of the official ones, but things like the Great Wall of China, were built by people who didn't actually understand what block and tackle was, which is one of the most powerful, simple machines that human beings ever created. And for over half of recorded history, people didn't know how to do that. But another fun one I've thought of recently is hot air balloons. The enabling technologies to have allowed people to have constructed hot air balloons probably predate writing by 2 to 4,000 years. We don't have precise timing on when high
Hmm.
fat linen was generated, but hot air balloons weren't actually created until the Montgolfier brothers, I can't remember which one of the two of it was, watched clothes drying above a fire and noticed that they billowed upwards in the smoke, and decided to build a very large drying dress, more or less, and demonstrate that you could float above the ground. And this is a technology that Ramses or Tut or early Chinese emperors could have had, but certainly didn't.
Wow. Okay. So creativity is kind of helping people make sense of the world, but also make leaps and bounds forward.
Yeah. There's a very real sense in which um, the chaos of the universe contains vastly more than we can be aware of, and by finding information that makes sense that we can interact with, we are leveling ourselves up in a way that's very deep and difficult to fully comprehend all the aspects of. Um, and that gets into sort of my passion around computational mathematics, because computational mathematics is essentially about the treatment of information as a what's known as a first class object. So information about how information can be processed, which you can then use on the information that's doing the processing, and create these things that are sort of at the same time daydreams, but also machines that can do things. And that is effectively what the computer is. The computers that we surround ourselves with are small manifestations of the partial concept of this general or universal computing machine, a imaginative system that is capable of encapsulating all of the possibilities of imagination, and which, like a djinn from ancient myth, will do anything that you tell it to do, but only specifically and exactly what you tell it to do.
Wow. I feel like maths is kind of the ultimate problem solver for you. If I'm reading between the lines there, it helps you make sense of that. But then apply it. It only does what you tell it to do. How do you know what to tell it to do? Is this where this comes in when you're noodling around with your maths? You're like, how about this? And just applying different strategies.
That's the basic challenge. So to find ways to hook these things into our actual experience, we have to have actual experiences. So I read and have been reading extensively for quite some time, and actually, have jobs here and there throughout my life, um, and have done some traveling. Not much. I'm kind of a homebody for the most part. I still live in the town I was raised in, but once again, it comes back to sort of that there's a big universe, so you can concentrate on basically any piece of it and get a an incoming stream of information that's bigger and deeper and wider than you can possibly hope to contain. Uh, and so you can take these sense impressions and inspirations back into your problem space and then see what happens. So, um, for example, my major project is CDM, this system for doing price discovery. I was initially thinking about uh, sort of consensus or fairness on networks. So people who have children might be familiar with the cake sharing problem. If you've got two kids, you get one of them to cut the last piece of cake and you get the other one to pick, and they both then have to agree that the outcome is fair, because if it's not fair, it's their own fault. Um,
Very practical, yeah.
yes, as it happens, there are fair division algorithms for dividable objects that work for any number of people. Unfortunately, those algorithms are what is known as exponential time. So if you have three kids, it's a lot more complicated. If you have four kids, it's much, much, much more complicated than the three kids example. If you have five kids, they're gonna be in college before they figure out how to divide the cake. Like it gets bad fast, and so the this is obviously a an important general problem, particularly as we're cranking up the amount of things that we plug into the internet. Um, And so I thought it'd be an interesting thing to think about, ways that you could negotiate a common interest in these sorts of fair outcomes. And I came up with an approach, and then I was asked a question, and it occurred to me that I could add recursion to the approach. And recursion is when a system can refer back to its own behavior as part of its operation, and it makes systems much harder to think about and much more powerful, which is like catnip to me, basically. Like that's exactly what I love thinking about. So I was like, well, that's a fascinating problem. Let's dive into that and see what happens. And what happens, it turns out, when you think about that specific set of things, is a brand new kind of marketplace falls out of the system at you, and that marketplace is more efficient than the ones we actually use. And that's something that's essentially been sitting there for people to figure out and communicate to each other forever. Uh, you know, this, as far as I can tell, math is sort of a feature of the universe. So human beings innovating fire, talking around the camp, could have come up with this idea, but there's no record of it anywhere. So that's creativity.
So are you saying that there's limitless amounts of maths problems out there that we can find and solve and work on?
Oh, beyond your imagination, quite literally. In fact, there's math problems about that specific issue of
Very meta.
yes, about the scope of imagination. There's something based around computational mathematics called the mathematician's infinite employment theorem. And there's a number of infinite employment theorems, actually. And basically what this theorem says is that there's no system that we could conceivably deploy that would be able to get to all the interesting math problems. And so anyone that wants to sort of break loose and throw their hat into the ring, there's low-hanging fruit somewhere, and you might be the person that picks it up.
And do you get to name it if you come up with a new maths problem?
In general, yes. If you come up with something that's really awesome, then usually the community will wind up naming the conjecture or the proof after you. In some cases, uh, this has led to a certain amount of confusion because certain superstar mathematicians like Leonard Euler, who's basically famous for having a name that is pronounced differently from the way it's spelled, um, created so much mathematics that there's so many things that are named after him that many people actually get them confused with one another. So uh, that becomes that becomes quite the challenge.
Surely there is a mathematical formula that could help that situation in the naming of new maths formulas.
Yeah. Well, uh, that's not something that's currently excited the community, but maybe someday.
I've got an opportunity here. I can just see it. So tell me, let's jump back a tiny little bit. So doing this type of maths, this is not your regular 9 to 5 job, is it? You have an interest in this outside of work.
Yeah. So typically, when I'm actually employed, it's doing data analysis or programming. And while programming has some relationship to computational mathematics, many actual valuable programming involves more or less plumbing, as it were, which again is a craft and a respectable thing, but not a deep creative object. So uh, the if you have incoming information, say web requests that need to be served at some particular rate, then you have a basic engineering problem. You need to be able to pull in these things, process them at speed, carve off the information that's appropriate. It involves a certain amount of measuring what's going on and sort of figuring out what parts are slow, what parts are fast, and then figuring out how to use well-worn libraries that exist to hook in to get them to operate the way it's supposed to be. But even there's a certain amount of design that exists that overlaps pretty heavily with the kinds of things that I find actually interesting. In terms of data analysis, again, there's so many different areas of mathematics these days. The AI approaches are largely dominating data analysis, but they usually require fairly large scale sets. And so many people are operating small or medium sized companies and don't really generate millions or billions of records on a daily basis. And if you're generating tens or hundreds of records, then techniques that go back hundreds of years are actually not merely sufficient, but actually better on average because they're easier and cheaper to deploy.
So is that why you've sort of strayed into maths outside of hours? Because your regular work is kind of logical and procedural and it's very set as to what you do. Is maths your child
Not
gonna let loose?
Not really. So, math is something that has always come relatively easy to me compared to most people. And so I learned quite a lot of it in school. But I would have more fun reading books or taking walks through the woods or the mountains and getting some daydreaming in that way. Uh, but once I became a professional programmer, my sort of engineering training kicked in, and we'd had some ethics classes on the concept of what a professional is. And a professional is someone that has mastered a body of knowledge that allows them to make decisions on behalf of others for others. And so you have to master a body of knowledge. And so now that I had this sort of engineering-ish job. I was like, well, I need to master this body of knowledge so that I actually am capable of doing it. And in doing that mathematical study, that's where I ran across this genie in a box, uh, uh, characteristic of computational mathematics. And that's where this sort of, having fun daydreaming type of pastime linked in hard to this actual engineering result where your daydreams could be turned into reality by the machines, and the machines would show you other things that were the results of the daydreams you were having, and this kind of entirely new world opened up. So it was something that I kind of fell into rather than being my release.
Wow. So you're having all these thoughts about various things, and then maths is your way of being able to actually enact that.
Yeah, it's a language that allows you to express ideas in much more effective ways. And so without that language, you would never really even be able to think these ideas. One of the classic examples is how sort of bad Rome was at math, because Roman numerals basically are terrible. Um, Adding Roman numerals isn't so bad. Multiplying Roman numerals is an enormous pain in the neck. Dividing Roman numerals is basically an object of torture. Um, Whereas our positional notation that we use these days is much more natural for those types of operations. And there's other ways of thinking about and representing numbers that are even more effective at doing those things. Um, so there's a few different sort of angles going on where you're attempting to develop language to allow you to think about things, but that language development is itself embedded in this language of helping you to think about things. So as you get better at developing these new language ideas, you get better at being better at developing these new language ideas, and you find yourself deep into the weeds very, very rapidly.
Yes. How do you do that? You're getting deeper and deeper and deeper. It's a whole cyclical thing. How do you know when to just stop? Is there a
Well,
cessation to these things?
sleep, food,
Oh.
there's the body will stop you at some point, and that's usually what happens.
So you said you have loved maths like your entire life. Did you always think it was a creative thing, or is it the daydreaming that has made you realize that?
I really didn't. I have quite the bone to pick pedagogically. I was extremely fortunate in sort of my schooling. I was exposed to enormous amounts of math, but I was still exposed to math as sort of a series of tricks, if you will. So, this is how you count. This is the order that numbers are in. And oh, by the way, now that you know that numbers are in this order, here's these shortcuts like addition and multiplication. And then there's these, division and fractions, and you keep building out and out from there. And each of these things, whether set theory or geometry or probability, were sort of presented as mechanical objects. It was just like, this is how the world exists. These are how these things are related. So it was like chemistry or physics. It's just like, if you stick some of this and some of the blue powder and some of the purple powder, and then you heat it up, then this happens. And so that's like how you add. And that was cool. I mean, I was very good at it. It was very easy for me to do these things. But the idea that there would be like different kinds of addition, um, I actually recall, I believe I was actually exposed to negative numbers, but in first grade, we were given an exercise set that involved subtracting, I believe it was 7 from 5, and I wrote down -2, and they marked it wrong because they were teaching first graders, and so they weren't going to talk about negative numbers, and so there was a bit of a disconnect where you know the boundaries were very much in place, and it was all presented as a set of boundaries, that these are exactly what you can do, and that's precisely what comes out. And that's fascinating in its own right, that there is this exactness that's possible. um, Certainly children don't have a lot of experience with exactness and precision in their ordinary day-to-day lives, and I certainly didn't. I'm still a bit of a slob to this day. uh, but that creative aspect didn't really sort of exist for me. And and that broke a little bit when we got into geometric proofs. It broke a little bit more when I started studying computer programming. um, but it didn't really shatter until I sort of wrapped my head around exploratory mathematics, and that would have been by the time I was in college.
Yeah. Wow. Yeah. Because I mean, I suppose my schooling was similar, not the 5 minus 7, which was what was the answer if it wasn't -2, by the way.
The answer was there's no answer.
Oh, oh, there you go. No, but I feel like certainly the schooling that I had in a few different countries, I actually went to school in 3 different countries. It was always that maths is logical, is definitive. There's one right answer, and there's one right way of doing things. And that's the opposite of creativity. It never sort of crossed my brain that it could be a creative pursuit. But I feel as though if you do consider it to be problem solving is a very creative pursuit. And that's essentially what you're saying there, isn't it?
Well, problem solving, yes, is essentially a very creative pursuit, and I, although again, for my standards of creativity, problem solving doesn't necessarily hit the high notes, because the problem would have to exist, and so to some extent the thing that you're dealing with is still sort of just existing within its scope. um
So you create the
Whereas,
problem, then solve the problem.
yeah, that might be more where the creativity lies. But within mathematics, there are these facts about ideas that, in particular, in the last 2 centuries, as the tools have become more and more sophisticated, and some of the things that have been thinking about it become more and more abstract, um, that are shocking and surprising. Um, uh, things like the quintic. So many people are familiar with the quadratic formula. If you have an algebra problem that with second degree equations, there's a straightforward way you can plug in the coefficients of the equation and pop out what the roots, the zeros of the equation are. As it happens, there's a cubic formula. It's a lot more complicated. There's a quartic formula, fourth power. It's a lot more complicated than the cubic formula. And for a while, people were looking for the fifth power one. They assumed it would be very, very complex, but they were checking it out. It turns out that there is no formula in fifth powers. You have to use other much more powerful techniques, and for 5 and all higher powers, because of the symmetries of the patterns of the roots that are possible in the complex plane, it's not possible for there to be enough information in a set of 6 numbers to to narrow that down to 5 answers. And that's true at every level. So there's, for a 100-degree polynomial, you'd have 101 numbers of information. That wouldn't contain enough information to tell you what the outcome is supposed to be.
Wow. Okay. This is getting so complex. And I feel as though is it important for you for people to feel like maths is creative?
I think that would have a lot of value because of the technology and the tools that exist today. That because we have computers and because we use them so poorly, or in some cases not really at all, the it looks to me like there's a lot of this low-hanging fruit lying around. There's got to be a lot of Montgolfier brothers out there that could just, notice, oh, when I do this ordinary thing with computational technology, obviously it would be possible to no longer have to some very important part of human society that takes up a lot of time and effort and whatever, because it's just like we can just slip the bonds of earth and float in the sky now. And I don't know what those things are, but I can't imagine that they're not there because nobody knew any of this stuff, 3 weeks ago, basically. Like this is all very, very new. And
Yes.
so having a lot more human minds looking at and getting curious and throwing themselves into this particular deep end strikes me as a very sensible way to let our imaginations loose.
Yeah. I mean, because all of this is so complex, it's hard to even comprehend what you're talking about half the time because it's so theoretical, right? And you can't put your hands on it necessarily. It's not tangible to me anyway. Uh, that perhaps is like a PR approach to rebrand maths as a creative pursuit. It will engage more people in it, and thus we'd be able to solve more problems in the world faster.
Uh, I would hope so. And in particular, the problem that might be most important to solve is to deal with the language, and work on some of these issues. So communication is hard in its own right, but we now have the mathematics of information, which is one of the key parts of computational mathematics, to talk about language. And there are some very powerful ideas there that are not part of the general discussion about how language and communication is structured. Sadly, most of that has been dominated by the marketing department, which is mostly about, did it sell product good? Did it not sell product bad? Which isn't entirely unimportant, but there are other things that you can do with it. So um, that's something that I think is part of that fertile ground, is finding ways to think about how to visualize or conceptualize and in most important fact, communicate a common understanding of abstract ideas, to get people on the same page, because there have been a few, at least half a dozen that I'm aware of, projects that where internet scale interested parties got involved in a mathematical proof, and the progress is pretty considerable. One of the more famous ones, there's something called the twin primes conjecture. So uh, going back to Euclid, we've had a well-known proof that there's an infinite number of prime numbers. Prime numbers have the property that the only whole number that divides them wholly is themselves, and one, of course, because one divides all the numbers. So 2, 3, 5, 7, so on. Some primes, and the early ones are sort of close together enough that we don't really count them, but primes like 11 and 13, primes like 17 and 19, uh, primes like 41 and 43 are only two apart from each other. And so they're known as twin primes. And we don't know whether or not there's an infinite number of twin primes. We know that they keep showing up as far as we can check, but obviously we can't check very far from an infinite standpoint. Um, And it turns out that it's a very hard problem to think about. Essentially, zero progress was made up until the 2010s, or maybe it was back in the aughts. So this math professor whose wife had a job out of state, and so he said he had a lot of time to think for himself, came up with a proof that there were in fact an infinite number of primes that were separated by no more than, it was something like a few million, um, which might not sound like much, but nobody had ever made any progress on this problem at all in the thousands of years that had been proposed. And he had the sort of the very first stake in the ground.
Yeah.
Well, an internet collaboration of thousands of people took his approach and did the work of chasing down all the screw tightenings and doing all the computational pieces, and got that number down into the thousands, about a month after he published his paper. uh,
Wow.
and so there's a lot of prospects for wide-scale collaboration if people can have a common understanding and interest in some of these abstract problems.
Yeah. Well, many hands may like word, right? And I guess it's just so hard for people to understand because the numbers you're talking about there are so big that you can't even count them, and that's why you couldn't understand these things, right? And so
Oh yeah.
people have no frame of reference for most people would have no frame of reference for the scale of these numbers and the complexity of all these theorems and formulas and whatnot. So I mean,
There are people who work in areas, this isn't sort of my thing, but there are people who work in areas of figuring out numbers that are so big that they have no reference except themselves.
see that is it. It's like, what does that mean? What does that mean? But no, I do. I agree. I feel like it is something that we should talk about more because it's obviously maths have so many applications across all of our universe and understanding and taking us to the next level that why not have more people involved, you know? And well, maybe this podcast will be that step, is just to lifting the veil on maths a little bit more.
Hopefully so.
Noah, I want to thank you so much for joining me today. I really enjoyed our complex chat.
Thank
And
you. Yeah, this was a lot of fun for me too.
and I also want to say thank you to everyone who's tuned in to Creativity Uncovered today. I hope this episode has inspired you to pick up a little maths and that it helps you summon creativity the next time you need it. If you've made it this far, a huge thank you for your support and tuning into today's episode. Creativity Uncovered has been lovingly recorded on the land of the Cubby Cubby people, and we pay our respect to elders past, present, and emerging. This podcast has been produced by my amazing team here at Crisp Communications, and the music you just heard was composed by James Gatling. If you liked this episode, please do share it around and help us on our mission to unlock more creativity in this world. You can also hit subscribe so you don't miss out on any new episode releases.